Here we're being asked to find the domain of the composition f composed with g. So we have a couple things to consider based on the definition of f composed with g. F composed with g of x is f of g of x. Now if we recall, a domain is a set of all x values. So we're trying to figure out what can be plugged in for x, or sometimes it's easier to answer what can we not plug in for x. But the first place that x gets plugged into is the function g. Now the x itself, the number that we're starting with that gets plugged in, that never necessarily ends up getting plugged into f. What's getting plugged into f is g of x, which might be a new number. So for our domain, we need to consider that our x has to be something that we can plug into g, and also that its output g of x is something that we are allowed to plug in for f. So that last part there is a little bit difficult to think about. And so there's essentially two things we check for when we're getting the domain of a composition. We look for the domain of that inner function g, and then we go ahead and evaluate that composition to get our new function, and look for the domain in that new function. And so then we'd have to combine any restrictions that we get from either the domain of g or the domain of our new function to create the domain of our composition. So let's start by looking at the domain of g by itself. G of x is equal to 1 over x. So we see that we do have a variable in a denominator there. Since dividing by 0 is undefined, I need to avoid any values of x that would make it have a 0 in the denominator. Since the denominator is just x, x can't be 0. And so the domain would be all real numbers except 0. And we could write that in interval notation or as a set in set notation by saying the set of all x such that x does not equal 0. I'm just going to shorthand it for now and say that x does not equal 0. So right away, because x is being plugged into that function g from the very beginning, x can't be 0 because that would make g of x undefined. Next, we need to go through and actually get an equation for this composition function, which without going through all the steps, this composition would come out to 4x over 1 plus 2x. So I'm looking at basically my final equation for the function here. Now you'll notice here that there would be no problem with plugging a 0 into this function. I would just get a 0 on top divided by a 1. Having a 1 on the bottom is fine. 0 divided by 1 is 0. However, because we had that restriction originally from g that x can't be 0, that restriction is going to remain there in our domain of f composed with g. And so we got to be careful and make sure that we're looking at that domain of g originally and not just at our final equation here. So looking at our final equation, we see that we still have a fraction. We do have a variable in the denominator. So we need to make sure this denominator is not 0. So I'm going to take that denominator and set it equal to 0 to see if we get any new restrictions. So solving for x is going to give us x equals negative 1/2. So based on looking at the domain of g, we can't plug a 0 in for x. Based on looking at our final outcome here, we can't plug in a negative 1/2 for x. So our domain of f composed with g, which is what we're being asked to find, includes both of those restrictions. And so I'll go ahead and write this out in both of the ways that are valid options for writing it. So first off, we have set notation, the set of all x such that x does not equal 0 or negative 1/2. Or you could also say the interval from negative infinity to negative 1/2, leave it out, meaning use parentheses, union negative 1/2 to 0. Continue to use parentheses to leave out those numbers, union 0 to 1/2. So just pick one of these two. Those are the two valid ways to write that domain.